Alright class, in this video we're going to do a quick overview of forces. Joke of the day, did you know that forces for a ton used to be 1,800 pounds, but then a guy came along and he changed the ton to 2,000 pounds. It was a new ton. Get it? Newton. Newton. There are three laws of motion. We're looking at Newton's laws. The first law is essentially inertia. That's an object at rest tends to stay at rest, or an object in motion tends to stay in motion. So inertia is the tendency of an object to resist the change in its velocity. Remember, velocity is just the distance divided by your time. If it's not changing that speed or rate, it has inertia. The heavier an object is, the more mass it has, also the more inertia it has because it's hard to move it. For example, these pumpkins will not move unless acted on by an unbalanced force. That means there's a push or a pull. Don't let this be you. Wear seatbelts. Because of inertia, an object, including you, will resist changing in their motion. Let's say you're going 80 kilometers an hour and then you hit this brick wall. Your body will keep moving at 80 meters per hour, and that will actually force you to go past the wall and you could get very hurt. But wearing a seatbelt resists the change in motion. Newton's second law has to do with the main equation they use in all your free body diagrams and whatnot, that says the net force in an object is equal to the product of its mass and acceleration. It's F equals m times a. Now the important part when doing equations with F equals ma, you need the net force. So for your net force, you would have to add forces if they both go in the same direction, or subtract forces if they're going in opposite directions. Think about a tug-of-war game. When your mass is in kilograms and your acceleration is in meters per second squared, your unit of force is the Newton. Newton's named after Isaac Newton, the guy that found the laws of motion. 1 Newton is equal to the force required to accelerate 1 kilogram of mass 1 meter per second squared. Weight is also a force. Instead of F equals ma, we could write weight is equal to the mass times the gravity. Gravity always points downward on an object. So let's say, for example, I have a person and I'm on a scale. Here's my scale. And I'm looking for how heavy he is. You're going to do the mass of the object, of the person, and you're going to multiply it by 9.8 to get your weight. If you want to convert pounds to newtons, 1 pound is 4.45 newtons. So then let's say you weigh 160 pounds. You can just use dimensional analysis. 1 pound is equal to 4.45 newtons. You would multiply the two to get your weight in newtons. And when you multiply, you get 712 newtons. There are many different types of forces in nature. If you have an applied force, push or pull, you usually use F of A. Gravitational force, you'll see it as F of G or W for your weight. The normal force is what opposes gravity. So let's say I have a table here. There's a box on the table. Your weight will be going downward. Your normal force is the table pushing upwards, and you write F of N. Since the block is not moving on the table, you have no net force. Those would cancel out and equal 0. It's important for free body diagrams to draw these. You can also have frictional force. It's F of K for kinetic, or F of S for static, non-moving friction. Tension in a wire is F of T, and you can have air resistance, F of A. Newton's third law of motion has to do with an object in motion will, for every action, there's an equal yet opposite reaction. So if you look at a bird here flying gracefully through the air, birds depend on Newton's third law of motion. When the bird pushes down on their wings, the air will push upward. That will help it lift up and keep them in the air. Alright class, so this covers just the basics of Newton's 30 laws of motion. There'll be many calculations involving net force, so check some of the other YouTube videos I leave on forces. If you have any questions, leave a comment down below.